Okay, now we're going to look at using formulas. So a formula is an equation in which variables are used to describe a relationship. Okay, for example, here's some examples. That's the perimeter of a square. It's 4 times each side. The area for a circle, pi r squared, right? That's probably one everybody knows. Here's an interest formula, principal times rate times time. Formula to convert between Fahrenheit and Celsius degrees. Okay, so formulas. So sometimes we might just be asked to find the value of the remaining variable. For example, this is the perimeter of a rectangle. P equals 2L plus 2W. And if we know that the perimeter is 126 and the width is 25, we say, well, then what's the length? All we got to do is plug in. If P is 126, right? And we're looking for L. The other one we're given is W, so nothing to plug in for L. Plus 2 times, instead of times W, if W is 25, 2 times 25. And then that gives an equation, like we talked about in the last video. You can only solve an equation if it has one variable in it, one letter, right? So this has an L, so I can solve for that L. Okay, simplify each side, do any math you can do. So I have 126 equals 2. I'm going to change that L like that. Plus 50. Okay, undo anything being added or subtracted to my variable. So 76 equals 2L. Divide by 2. So I have L equals 38. And I have found the value of the remaining variable. Okay, so if I'm evaluating using formula, it's just plug in and solve the resulting equation. Real simple. Okay, now we're going to talk about actually using a formula to help us do some more application problems like last time, except this time we won't have to come up with our equation because it'll be a formula. So that's helpful. So the perimeter of a two-dimensional geometric figure is the measure of the outer boundary of the figure. Wow. What words? The perimeter is you add up all the way around the outside of the figure, right? That's what they just said. Okay, so for a polygon, the sum of the lengths of the sides, add up around it. Okay. Okay, so if a farmer has 800 meters of fencing material to enclose a rectangular field, so these are some of the cases where diagrams really help, a rectangular field. The width of the field is 50 meters less than the length. Find the dimensions. Okay, the width is 50 meters less than the length. So it's the same as the length minus 50. It doesn't tell me anything about the length. But I know that he's got 800 meters. So all the way around it, the length plus the length minus 50 plus the length again plus the length minus 50 again, that's got to equal 800 because that's all he has. Here's the two lengths and here's the two widths, right? Length plus width plus length plus width. Now I've got an equation. Like terms are 4 L's. Okay, minus 50 minus 50 minus 100 equals 800. Let's add 100 to both sides to get rid of that. So 4L is 900. So he needs the length to be, what is that, 225? Let's check, right? Let's double check. I'm not sure because I don't want to make a mistake. we are, 225. So the length, and that's in meters, so once again, I need that meters on there. 225 meters, a lot of difference in 225 feet. Okay, but it says find the dimensions of the field. So I not only need the length, right, I'm going to rewrite it up here since we're running out of room, but I also need the width. And the width is simply the length minus 50. So if I subtract 50 from 225, I get 175. So it's 225 by 175 meters is the region that he can enclose with his fencing that he has, if he wants it to be rectangular. Okay, let's try another one. The longest side of a triangle, oh, we got a triangle. The longest side of a triangle is 1 inch longer than the medium side. The medium side is 5 inches longer than the shortest side. And the perimeter is 32. Interesting. Excuse me. Okay, here's my longest side is 1 inch longer than the medium side. So this is the medium plus 1. The medium side is 5 inches longer than the shorter side. So the shorter side plus 5 is this medium. And then it just says the shorter side, so I don't know anything about the shortest side. Okay, now look at this. If I add these, because perimeter just means add up all the sides, right? So if I add all these together, I'm still going to have S's and M's. I can't solve that with S's and M's. Let's go back and think some more about this. The longest side of a triangle is 1 inch longer than the medium side. Okay, here we go. This is the longest side of the triangle. Okay, the medium side is 5 inches longer than the shorter side. And of course, this is the shorter side. All right, so another way I could write this, if this is the medium side of the triangle, if this is the longest side of the triangle and it's the medium side plus 1 inch, here's the medium side. So here's what I could do. Here's the longest side. I'm writing up the longest side. It is the medium side plus 1. Does that make sense? Okay, the longest side is 1 inch longer than the medium side. But what I know about the medium side is it's 5 inches longer than the shorter side. So basically, that's the medium side plus 1 to give me the longer side. Okay, so now that we've got the longer side, here's the longer side plus the medium side plus the short side. And that has to equal 32. Okay, look at these. I hate it when we have S's. I'm going to switch this to maybe a capital S, right? Just so there's no confusion. Not a capital, it is capital, but a capital cursive S. Okay, so 1, 2, 3 S's. So I've got 3 S's, right? And then here's 5 plus 1, 6 plus 5, 11. Plus 11 equals 32. Okay, my 3 S's, and then the numbers. All right, so we got to subtract 11 from both sides. That gives us 3S equals, because that's gone now, 21. So if I divide by 3, I know that the shorter side is 7 inches. That means the medium side is 5 inches longer than the shorter side. So the medium side is, oh, seriously, dude? All right, let me see if I can get that off of here. No, I don't want to erase. Okay, I'm going to go ahead and do this over that because we're nearly at the end, because I think I have to erase everything to click that button right there that says cancel. It's trying to update my computer, which is stupid because I can't update it anyhow without tech support signing off on it. So technology, right? Okay, let's back to what we were saying. So the medium side is 5 inches longer than the shorter side. So 7 plus 5, it's 12 inches. And then the longer side is 1 inch longer than the medium, so 13 inches. All right, let's see if I can get rid of that. Yes. Oh, it's off my stupid thing. Will it let me? It did. Okay. All right. Sorry about that. The area of a triangle is 120 square meters. The height is 24 meters. Find the length of the base of the triangle. So they expect you to know a couple of formulas. And when it says the area of a triangle is half base times height. Okay? If you have to look it up, you can look that up, but I need to know the area of the triangle. Okay, so the area is 120. So this is like that first one we did, where we just plug in if we know the bits and we've got a formula. So the A is 120 equals 1/2, and the height is 24. I'm looking for the base, so the base stays, and then times 24. Okay, first thing I notice about this equation, it has a fraction. So multiply every term, right? Not every number, every term. Okay? So that will divide out. And we have 240 equals, I'm going to flip it around and make it 24b. B times 24, 24 times b, doesn't matter. Multiplication is commutative. Okay, and then divide by 24. So 10 equals b, and I need that to say 10 meters. We found the length of the base. Make sure you actually answer the question. Excuse me. Okay, solving a formula for a specified variable. Sometimes we want to rewrite the formula in terms of a different variable in the formula. For example, a surveying class might need to solve the formula for the area of a rectangle, which is A equals length times width, area is length times width. Suppose that in every problem they're working, right, the area and the length is what's given, and they're trying to find the width. Okay, so rather than plugging in and solving for W each time, okay, like we just did, it'd be simpler to just rewrite the formula so that it's already solved for W. This is called solving for a specified variable. Okay, and so the great thing about that is we have to be told which variable we're solving for, but then after we're told that, we treat all the other letters in there, the other variables, as constants, and we use the exact same steps. All right, so let's see what that's going to mean for us. So solve interest equals principal times rate times time for the time. Okay, so I'm just going to imagine that the t is my variable, which means here's the steps for solving an equation. Get rid of any fractions. We don't have any. Get rid of any parentheses. We don't have any. Right? Simplify each side. There's nothing to do on each side. Okay? Put all your t's on the same side. I don't care about the other variables. Put all your t's on the same side. It already is. Undo anything being added or subtracted to your t. Nothing is. So finally, undo anything being multiplied by the t. Oh, okay, t is being multiplied by PR. So I undo multiplication by division. I just got to do the same thing on both sides. That means this will cancel and this will cancel. And that t is all by itself. And once you have t all by itself, you have solved it for that variable. Now, if you continually know what the interest is and the principal and the rate, but you always need the time, you can just plug in here, plug in here, plug in here, and not have to go through the solving steps over and over. You can just plug in and evaluate. All right, let's try it again. This time, we're solving for h. So we just keep in mind, this is my variable. Okay, there's no fractions or parentheses or math to do, right? The h's are already together. So undo anything being added or subtracted to it. I'm going to rewrite it just for us. So my first step really is to undo anything being added or subtracted to my variable term. So I've got to do minus 2 power squared, whatever I figure out I'm doing on one side, I have to do the same thing on the other. Now the only difference in this and an equation is I can't combine those in one number. You know, in a regular equation, this would be a number and I'd subtract another number. But here I'm just going to have to leave it s minus 2 pi r squared, right? Because I can't physically combine them, but it's okay. It's just going to be a formula anyhow. Okay. So then I undo whatever's being multiplied by my variable. Since all this stuff is being multiplied by h, divide by it. And I'm going to divide everything over here by that. Everything. I have to divide the whole side. Now typically, we just have one number there. And so it's, again, math we can do. But here, divide the whole side. Now once you get the variable in question all by itself, you have solved for that variable. Now I'm going to mention one aside here. From this point right here, sometimes some people might say, okay, well, I know I need to divide everything by this. And so we could, as long as we did everything, do it individually. Now, not only will this stuff cancel, but some of this stuff will cancel also. Now, the only thing, I'm going to have one of these r's will cancel because that's r. These both technically are correct. Your homework is going to want it like this, though. Okay? Okay, but notice what it is not. This will not cancel in here, right? It is not, you know, that s will not cancel. I've got this minus here. So I can't cancel with a minus here. If I'm going to do this, it's got to be individual fractions, not all together with a plus or a minus. Be very careful about that. Okay, there's the Fahrenheit Celsius conversion. And it says solve for C. What's the first thing you notice about this equation? Right, fractions. Oh, but hey, it has an equal sign. So I'm getting rid of the fractions. Multiplying every term. I didn't multiply the number and the letter, right? Every term, not inside parentheses, but I don't have any, by 5. Now that'll cancel. And we have 5 times F equals 9 times C plus 160. Okay, now we're solving for C. So I've gotten rid of the fractions. There's no parentheses. I need to keep this in mind, what we're trying to get by itself, right? No math I can do. So undo what's being added to the C first. Okay, this is two unlike terms. They're not alike, so I can't combine them. Okay, and then divide by 9. And again, I'm going to divide just that whole thing by 9. You could separate it, but this is fine. Okay, let's try it one more time. Oh, solve each equation for y. Okay, so this is something that we're going to be doing a lot, solving things for y. Okay, so same idea. There's no fractions or parentheses or really any math to do. So start by undoing anything being added or subtracted to the y. Remember, we're solving for y. So now that's gone. Y equals 4 plus 2x. Okay. Undo anything being added or subtracted to the y. Okay, and let's divide by 3. Now in this one, when we're solving for y, we're going to tell you something different. Technically also, they should not count it wrong if you write it this way. But really, when we're solving for y, we usually want that x to come first. So we'll typically write it this way. It's not wrong to write it the other way. Just when we start graphing, it'll make it easier if we all write it the same way. And also, if we're just solving for y, they probably want you to do that individual thing like this. Right, so that you can simplify a little bit more. And you can either write it like this, x over 3, or 1/3 x. Either way. But once again, they're probably going to want that x to go first. Okay. Good luck. Let me know if you need anything.